Oh, my neck hurts. Look at that thing leaning on my neck. Ah, that hurt. Anyway, here we go. Now let's move on. Now we've got section 7.4. We're going to be combining some radicals. Of course, this is the easy one. Why is it the easy one? Well, let's see. It's an easy one because they have something in common. So all we're going to do is we're going to go 5x plus 2x minus 9x. All of that times radical 6. Well, if you look at that, that's 7x minus 9x. It's negative 2x radical 6. As I said, that's the easy one. Here's the hard one, a little bit harder. What do we have to do in this case? Well, we can't really do it. Can't really do it except because they're different, right? But look at this. We can actually change this first to the square root of 4 times 3, which becomes the square root of 4 times the square root of 3 plus the square root of 3. Well, this is plus or minus 2 radical 3. We'll leave it as a 2 radical 3 plus radical 3 equals 3 radical 3's. Got it? So we changed this radical 12 to radical 4 times 3, took out the square root of 4, leaving this radical 3 to go with that one. A little more difficult. Why is this one harder? This one's a little bit harder because denominator of 1, denominator of radical 5. So we have to have the same denominator. So what I'm going to do is I'm going to first multiply this by the square root of 5 over the square root of 5 because, as you remember, yes, tell me everyone, yell it out as loud as, no, we don't want to disturb the neighbor. This is 1. So we end up with 3 radical 5 plus 5 over radical 5, which equals 8. I'm standing in the way, which equals 8 over radical 5. But there's this little rule that we can't leave it in that form. We need to rationalize it, which I believe comes up on another one. So the way we do that is, again, we multiply by 1, and we call it radical 5 over radical 5. We end up with 8 radical 5 over 5. As I said, that's a little harder. Now let's go down to the hardest one of all, because it looks like there's a whole bunch of stuff there. Did you miss that? Pause, pause, pause. Never mind. Okay, here we go. The teacher or one of your students can fix that. So anyway, what's going on? Don't have the same radicals, do we? They're both the third root, so that's good. The index is 3. So what we're going to do here is first we're going to change this up a little bit. So it becomes the cube root of x, never mind, we're going to just skip right down to it. 2x, the cube, y cubed matches this cube, so y comes out, and that leaves the cube root of xz squared. Minus 6, here we can take out an x, because x cubed times x is x to the 4th, so we end up with an x and a y. What's left inside? The cube root of xz squared. Notice that we now have the same radical. So they become like terms. So we end up changing it to 2xy minus 6xy times the cube root of xz squared. We can actually do this and end up with a negative 4xy times the cube root of xz squared. As I said, that was the hardest. So take a look at it. Let me just ponder it with you, okay? What do you think? Got it? Thumbs up? Thumbs down? Eat your thumb? Anyway, let's go on. Here's the next one. 7.5. Rationalizing the denominator. We actually did that in the second thing, but this is more intricate a little bit. And what we're going to do in order to do it, we're going to use what we call the conjugate. That's the wrong. It's not the complex conjugate, it's just the conjugate. Complex conjugate comes up in section 7. So we're going We're going to multiply this by some name for 1, so we eliminate the radical down here. We don't want radicals in the denominator. And the way we do that is we're going to multiply by radical 5 plus 2. Because when we do that, just like x minus 3 times x plus 3, there's no middle term. It's x squared minus 9. That's what we're doing when we do this. We're using the same concept of minus and plus to eliminate a middle term. So how do we do that? Whoops, get out of here. Whoa, can't get rid of it. We'll fix you. Ha! All right, so when we do that, again, we're multiplying by 1. We end up with, move that harder one down here. We end up with 3 times radical 5 plus 2 over 5. That's radical 5 times radical 5 is 5. If you want to get technical, you end up with negative 2 radical 5 and positive 2 radical 5. And negative 2 times 2 is negative 4. These, of course, cancel out. These right here. Those right here. Cavities. And what is this? That's 0. 5 minus 1. 5 minus 4 is 1. So we end up with 3 radical 5 plus 6 over 1. That's harder. That's more or less easy. Gets a little harder. We'll do this one right here real quick, and then we'll move on to the last section. And believe it or not, it's almost time for third period. That's 10 p.m.? Okay, it's not third period, is it? We're going to do that same concept here, only this time we're going to use the conjugate of this, which means we're going to multiply by 7, a radical 7 plus radical 5 over radical 7 plus radical 5. So these are conjugates. There will be no middle term, no more radicals. Radicals will disappear. So in the denominator, and I'm going to go ahead and move that down right here, we end up with radical 7 times radical 7 is 7. No middle term because this is minus and this is plus. And then we end up with radical 5 times radical 5, and that's minus 5, which equals 2. So we'll leave that over there. We'll get to it. Then on top, we're going to end up with 7. That's radical 7 times radical 7. And then we're going to have radical 35 plus radical 35, so that's plus 2 radical 35. And then radical 5 times radical 5 is 5. So now we can actually combine the 7 and the 5, and we get 12 plus 2 radical 5. But, again, that can be simplified a little further. So we end up with 6 plus radical 5. That's section 7.6. The last one we're going to look at, 7.7. So please, I can't talk. I'm so tired. It's just so late at night. 7.7. Am I giving you enough time to change your notes and move on to the next page? Hey, you guys back there in the back, you're always giving me a hard time. Get out. Just go away. There, they left. That was the door closing, not the stool. All right, 7.6, we can also